Have we got sound? Does that work? We've got Peter. I don't know if we've got sound. If you do a sound check for us, that'd be great, Peter. Maybe we haven't. Yeah, I think we do. I think we should. Don't know, I might wait and see. Well, wait a minute. I didn't advertise this at all, so people have probably forgot it's even happening. A bit slack with that. Thanks, Peter. Not really sure where this is going, or whether I should keep it going, or whether it's something people are interested in. Maybe it is. I don't know. But anyway, might start with the very little CAD work that I've done this week. Which, to be honest, isn't much. Been a weekend. Oh, that's a big yawn. Work tomorrow, which I'm unimpressed about. Queensland's accused the holiday was yesterday, yeah. Bit of a pain. So these are the motion guards for the roller. This is an ongoing thing and not a very simple thing, to be honest. A little bit complex. They're both different, and they've both got some interesting bends and things in them. I've done them as sheet metal, and if we fold this out, you'll see the sheet metal patterns with the different curves on them, and the rivet holes around them and the bend lines. I've exported them as DXF, which is quite straightforward, really. Which is an AutoCAD file, which most laser cutting and so forth machines will be able to read. Right click on that and export DXF DWG, a flat pattern. What you want to call it, format you want to use in the version. All flattened pattern parts, or single flat pattern, or all flattened parts in flat pattern parts in the Part Studio. And you can download it, or you can download it and store it in the same stuff, store file in a new tab, whatever you want to do. Include the bend center lines, bend tangent lines I've left out, counterbore and countersink lines we don't need, form feature outlines, and visible sketch, etc., etc. If we click export, that saves that as a DXF file, and that should be okay. You could add DXF viewer and check them, because it's not a bad idea before you spend money on actual cut metal. But if you send that to a laser cutter, they should be able to do that pretty straightforward. Same with the printer. We've got we'll click on this one. This is what it looks like all assembled. It's got a plate on here. If we wanted to 3D print that, we can just click on it and click export, and that'll export it as STL. It will give us options. Hello, Mark. But you know, all those things you can export as STL or Rhino NURBS file or Calendar or SolidWorks, Parasolid. If you want to use it in a different program, you can just export it straight across. And there's a few things you can change, but that's straightforward. Anyway, that should have a piece of brass around the bottom here. I've got that brass. I think I showed it Tuesday night. On the back, there's there's two brackets like this on the back, which bolt on the holes, and two brackets on here, which bolt on the front. They look like this. Do they? Yep. Probably. Good question. It's not what we want. This is the one we want. We've got a poor connection again, of course, because internet's crap. How did you cope? Pencil. As far as getting things like this cut, I've elected to weld these out of two pieces, and basically export this file with this pattern here and get it cut, and this pattern here and get it cut. And we've got the two short bits. All we've got to do is put them against a piece of RHS or something and weld the back of them, tack them, and weld them up. It's a pretty straightforward thing. So looking at these, this is one of the jobs that's on the laser cut list. 1 3mm plate, so they're fairly solid. Press N. It's a really good thing to remember because that gives us a normal to the given view. If this is sort of something like that, and you press N to the front view, right view. This one's for the low pressure cylinder, and this one's for the high pressure cylinder. Now, I took some measurements. It's a very difficult thing to measure off the roller. Almost impossible, actually, because nothing sort of touches anything else and everything's round and everything's got something in the way. Not an easy thing. But I also found a drawing of the trunk guides, or the the guide bars, which had the correct dimensions on here. And have a look here. Feature list down here. And find a sketch. There we go, it's one of these. There it is. Turn that sketch on. There, and that's the front covers. I guess you could draw these out or text them. It's such a difficult job, even with CAD, that honestly, it's probably easier just to do it. This is such a godsend to be able to do it like this. So these sit up against here. These are offset. So this cylinder, the crankshaft, this isn't actually in the middle of the engine. It's about 5/8 of an inch. No, it's more than that. It's 1.5 inches offset from the center of the cylinders, which is there somewhere, to the actual center of the thing, which is there. I think it's about 1.5 inches. So these have got to be the same distance from here to here and here to here. And hopefully these bolts that pick up are the same pretty much between here, or between, say, this bolt and this distance here. They're within a couple of millimeters, so that'll do nicely. Be plenty good enough. So that's that. That's the motion covers. I don't know if they're too high or too heavy or what they are. I believe that's what size they were, 15 inches. From a Jeff Mueller sketch on a bit of writing paper. But that's one job we've done. What else is there that we've drawn up? That's not it. Don't know. Let's go back. We go back to home here. We've got quite a lot of them. This is ash pan clips. This is another job that, no, it's not. It's not even close. Ash pan clips. There you go. Oh, fold on you. Spot on, Peter. Find them from where it actually starts, or what the point is on a big round surface is a bit different. Wait for this to load. These are the ash pan gibs or cotters or whatever you want to call them. There's two of them. They've got a hole through both of them. We'll line them up with a pin or hook them over an edge, and we'll attack them here and here. This hole and this hole. And then this part here from here back is so we can separate them a bit. And we're going to put them. They should be really good. They're just very simple parts. This one here is for a job that I intended to do this last weekend and I never got to because there's no way to really do it. And that's a drain plug or a washout plug in the bottom of the smoke box. Sort of fairly important, and I'd like to get it done soon. But we need two plates that look something like this. And we just tack them on the smoke box nice and level, and tack a bit of plate on the bottom. And then we can sit the mag drill on it upside down, and we can drill a hole up through there, through the middle there, and grind all these off and paint it, and everything will be nice. So that's probably the best way to do that. So we're getting a couple of them cut. This is the fowler gear cover, or from the drawing. This is the steering gear cover, new one. So it's a new piece to go around the outside in sheet metal, flat, 3mm, and the big piece for the outside. Hopefully they should line up nice. They should roll up or tack around there and roll it up nicely. And the holes all should line up for the new, except that one. That's going to need to, now I'm glad I come back and check that, because this one's in the wrong spot. These holes here actually in the wrong spot. Let's go and change that quickly. 1.5 and 1.5. Now this should be, if we delete this measurement here, and we'll put a new dimension from there to there, call that 1.5. And click OK. That should easily fix that. So there we go. Now they're all in the right spots. Top view. So that's other parts. It's another part. There's this one here which is slightly different, and I've sort of scaled it down and taken it off the drawing, etc. This should be somewhere near right for Mark's cover. So that's another piece that's on the list. So that's sorted. Wonder who else is joining us here. There's a couple of these. Now, Mark, let me know that you had both of these. Had the two of them. Get another one cut if we need to. I might get an extra one cut anyway. Mightn't hurt. So the other thing that we've had is that we've got a set of running lamps that really need electric light, and we got electric light sort of sorted out to a certain extent. We've got globes and light bulbs and batteries and globe holders and switches. Really nice sort of a system that gives a good light and looks like it will work quite well. Looking at this is sheet metal, and whether I steel or 0.5 would be plenty good enough, because it's not actually spot welded together. It's only, you can spot weld them, but they're really only just screwed together fairly simply and easily. Probably aluminium is plenty good enough. So this is what I've drawn up. This is an interesting little part. Looking at it. We'll get that cut, and this tab in the middle folds up and the battery sits in there. It's a hole for the wire to go through, and this actually is the right size to sit inside the lamp with a handle on this end to hold it, a switch, place for a switch, and 2 tabs that we can bend over to put a couple of screws in, just to hold it all in place. And then the circuit board bolts on these 3 logs here, these 3 holes with standoffs. So basically, if we look at the assembly, this is a bit rough the other night. It's getting late, but the circuit board goes on here. The light globe goes in here, and the switch goes in here. And the battery sits in underneath against that with this folded up. It just drops in. So they should be really good, I think. I think they'll be excellent. That gives us about the right height, and it gives us an on-off switch right at the front. And if we put them out, we can see how much voltage is in and everything else really easily. And probably plenty good enough. Battery separate to the circuit board, so it's not all banging around in there. I think they'll be very good. So that's something I've been working on. Looking at the sheet metal model, if anyone's sort of interested. Look at the sheet metal model for that. There's actually 2 pieces because I haven't included that one back in it. I've decided to leave that out. So this is the piece for it. Now if we get that laser cut and bent up nicely, it should be a very simple job in aluminium, just to bend it up in the vise or in the folder. Get all the bends right. Whack a couple of little looking at it, drill through them and tap them. Screw a couple of screws in, or put a couple of pot rivets in, or whatever it needs. Hold it in place. Bend these over and do the same with these. Probably going to bend these over and actually pop rivet them, which will be easy. Little screw, little switch is probably okay. Pop riveted in too, with 3mm pop rivets. I don't know. If you got to get it out, screws might be better, but they'll come loose. And the light bulb just sits through from there, and I'm going to make basically a 3D printed ring to push over it, friction fit, hold it in place nicely. And we'll get just some Dick Smith or J-Car nowadays, standoffs and screws just to hold that up. I probably got them here in stock. So use plastic screws so everything doesn't short out. And that should be really good, I think. That gives us pretty much the same dimensions to the middle of the light source as the originals. And pull them out, unplug the battery, recharge them, swap them over, whatever you need to do. And there's 2 of them. I haven't even looked at the rear one, which will be similar, different size. So that's sort of how that's working. I think that'll be fun, and I think I'd just probably aluminium, but look, if they just want to cut them out of steel, that'd be plenty good enough. Brass might work, a bit more expensive, but if I cut them out of brass, I'd just soft solder them. But probably cut out of steel, a bit of zinc, it'd be zinc seal in 0.5, it'd be really good. Good solid, easy, you can nearly stand on that without doing it any damage, so that'd be really good. Anyway, that was another job that we did when we had nothing else to do. They're all things that are on the list of the laser cutting list that need to be done. So we've sort of spent a bit of time on those in my off hours this week, which hasn't been many because I've been away for 2 days, and so on and so forth. Anyway, that's what I've done. Let's create a new document and have a look at something. Actually, let's go back to last week's and have another look at this flywheel. Having had a look at it over the weekend, it looks nothing like a fowler flywheel. So I didn't have anything to do. Has our microphone dropped out? So this doesn't look very much like a fowler flywheel at all, to be honest. I'm back, righto. What I did do, and we'll go for profile sketch, which we labeled, and edit that up. It did drop out, yeah. It said it's no longer connected. There's a connection problem. So this is what I've done, and I've made this so that we can actually change the dimensioning without actually messing this up, because just in case someone had time to mess around with it. I reckon this is 48 inches diameter for a start. And that sort of works. I reckon this is, the flywheel edge is probably 1.25 inches, so we're going to go 46.5 to the edge. This has got a bit of a, this is where this is. If we rebuild this, and put a measurement from, say, here to here, up here. This is something we can do. If you want, if you put a measurement or a dimension in and it goes the wrong way, you can just go -2, and that'll put it back the other way. So that's a bit of an offset here. Now, this, I think we've got a line that goes up here like this. This is just guessing. I reckon about we're guessing 7 inches. And another line that comes down here. From this one. We can make this any angle we like, but when it goes parallel with the other line, or parallel with the line we've just drawn, it gives us a yellow dot. And if we actually highlight that, it'll give us a yellow dot across there too. We probably want some sort of spline. Which gives us a couple of, pull in here. We can pull this one down here like this, sort of. Pull this down parallel to that. And this one up, sort of parallel to that. Move that down there. The it gives us a spline that looks something like that. Now, if we measure this across here, we don't have to put it in. I mean, if it's getting a bit crowded or you think, we can use this little measuring pier inside the sketch, which is down here. And all we've got to do is select the dot and the line. And that'll give us a pop-up with a distance. Now, this is on the Y plane. You see that up here on the direction? It's 31.75 millimeters. That's in millimeters. If we change this to inches, which is what we're working in, 1¼ inches. So if we use this one here, which is offset, click offset, click this one, this one, this one, click this arrow to change the direction, click on that dimension, it's telling me that there's a join problem here somewhere. Where is that? And it looks like it's probably here. We've got 2 dots there somehow. We can still offset this one. And we can still offset this one separately. But for some reason, there's a join up problem and we need to find out what it is. And we can offset this one separately too. And for some reason, it all seems to overlap. We've just got to trim the edges and grow. We'll trim this one. Remember to click the scissor icon, not the dimension icon. Trim this one. a duplicate line. The same here. Let's tidy that one up. Click on the right again, or on the, bring it all back in. Clicking on the end will do the same thing. Actually, it'll reverse it, because we must have drawn this on the left plane rather than the right. Can trim that, and it all looks really good. Now, if we finish that, because that's still the same surface that we're doing, that gives us sort of the right curve. I'm not sure if it's exact. These here, looking at the front of it, these handholds are not anywhere big enough. Now we've changed the size. We've already named this one handhold, so that's easy to find that sketch. We can edit it up. We can change this to, let's go 30. Not really big enough. 44. Too big. 41. Probably not terrible. Facebook, that will probably this computer. But we'll just wait for that to work itself out. There we go. These three holes here for the dust cover, there actually should be 4 of them. And that's an easy repair, easy change too. Actually got, have a look, 3 incidences on the PCD. Change that to 4. Fixes that. We can close that. That looks more like a fowler. Now there's three gussets in here. There's several ways we could do that. You could draw them in separately and array them. I believe that there's probably a function here. We still need the sketch profiles, but that will actually do it. We can just bring that out. What we can do is we can either suppress this, which suppresses everything going forward in the whole feature list. So just to show you, if I suppress this, click suppress, it doesn't do anything. It suppresses all the features that we've done forward to that. So if we unsuppress that, Mark has 5 holes. Okay, mine has 4. What we can do is come down here to part 1, and we can rename that. It's a really good idea. if we right click that, click edit appearance, what we can do, we can wind this back so it's nearly transparent, so you can actually see the sketch through it. Right, or we can go over here to this and we can drop this down, and there's a function here where we can go translucent. Now that's not any easy to read, but if we click we can change that up so that it actually so that's one way to do it. Probably all we need to do though is just click that little eye, which is another way to do it. And that just hides that particular part. This needs we'll get some of these other details in first before we start. But put another sketch on this one. We can click the right plane, or we can click the right plane here, or and all we need to do is put a gusset in. It probably doesn't need to be a lot more complicated than that. You can make it look pretty, or you can offset this line, and or we can use that line if we use this little square box, which is the use or project button. If you think this looks ugly, once it's part of the model, you can't actually tell where it begins and ends. So we'll put a new sketch in. We'll call that one gusset. I reckon it's probably 3/4 of an inch thick. We can either type 3/4 like that. That's not right. That gives us an inch. 3/4 like that, which gives us 3/4 of an inch, or 0.75, or whatever, 19 millimeters, whatever you want to do. You're going to make it symmetric, so it's offset each side. And then if we block this out, we've got a gusset that looks pretty good. Use our circular pattern. We want to pattern that. The axis of the pattern could be anything, but with it outside the flywheel. We want to add them in. Select our merge scope. If it doesn't do it for us, this is the flywheel. Something like that, maybe. I reckon this should have a fillet around it. Something like that. And probably a rounded edge on top. Now we've got something there that we can't click off that very easily. So if we just go back here, click on the outside, that'll fix that. Now this is giving us a pink line, which is not actually an error. It's just telling that there's something overlapping. Our radius is probably more than the thickness of the rib. And changing that fixes it. Anyway, starting to look something like. I'm going to have a quick look at Mark's photos because I apologise if this crashes my internet. I'll have a look here. So looking at Mark's photos, I think we're back. The T3 flywheel is quite a lot different than the DNA flywheel. This is what mine sort of looks like, right? Just looking at it. To my mind, that's pretty much exactly what it looks like. I don't think the profiles or the curves or anything are quite right, but looking at black fowler DNA flywheel on mine, that's very similar to what it's got. Now, Mark's is only 2/3 that diameter. Let's make a new one. Part studio. We'll create new part studio. If we don't want to start once, we've already got a reasonable start, I guess. What we can do is go down here and select duplicate. And that gives us a flywheel copy. If we open that, we can probably draw up something pretty good for Mark's pictures. Wait till this loads. And what we've probably got is nothing like this. Let's go back to profile. Now Mark's is only 36 inches diameter. We'll call the inside one there 32. And this one here that was 48 will go for 36. So there's quite a bit of size difference. I don't think it's got a 2-inch thickness wall rim, so we're going to go 33. It's a good start. It's only a tiny little flywheel in comparison, see? Now, let's have a bit of a look at these pictures. This distance here, if you can still hear me. This distance on the front here is actually, let's have a look at this. It's not 3/4 of an inch, it's 32 millimeters, which is that right? 1.25 inches? People who have metric tape measures, I don't know. 32 millimeters, inch and a quarter roughly. 1.25. 1.25 inches. And it's done some strange things here. Bring that round. Might just trim that. This doesn't quite line up, so we'll click this one and extend. And we can easily extend this back up here without putting another node in there. And click trim. And that'll select that part and trim that off. We'll put a measurement on here, which 1.25 millimeters. This one here, I'll put that in later, so we'll delete that. And this one didn't do anything, so we'll delete this one too. And put some new measurements in. We'll measure that line. 1.25. That changes that dramatically. Change the diameter in there. We clicked N again, which is the wrong way around, so we'll do that. So that fixes that problem. Let's have a look at the next one. That's a handhold dimension. We'll get to that in a minute. There's a spigot sticking out. It's 38 inch and a half, inch and 3/4 long. So this one here should be 1.75 long. It's given us a red dot, the red mark there, and the reason it's given us a red mark is that I've actually used a comma instead of a full stop, so it's a syntax error. That fixes that. Now it's only 95 mil wide, which is 3 3/4 of an inch. It's not a very wide flywheel. Let's fix that. It says there's 6. I see it's an odd shape for the key, and it's got six gussets, quite solid gussets in it. It's also 60 mil diameter shaft. It's only a little crankshaft. 2.5 inches. 2.5. So we could change that one too. Let's keep going. Looks like the boss is about 5 inches diameter. Change that one to 5. It fixes that. We've got some measurements for the gussets. It looks like it's an inch flywheel. 30. I'm going to go 36.5 for the diameter. Right, so that's given us a few more dimensions. There's a radius on here. I'll come back now. I could just type it in millimeters, but we know it's probably 2.5 inches, so we'll convert it across. Save a little bit of confusion later. Now this here has a 5-inch shaft here, and then it's got a big radius on here. So I'm going to draw this. We'll put another line in here, something like this. Press escape to finish it and use the scissors. We can zoom that in if we can't find it. So what we've got is this has got a radius on here, so we can put that on too. Just to fill it. We can radius it afterwards. And that doesn't work. Too big. That one does. So that's as much measurements as I've probably got. That's probably more like what it is. If we use this little tape measure to see how far out we are here, measure there. Because it's a metric measurement, I've got 510, so it's nowhere near that big. Go back here and edit the gusset measurement. And shut the flywheel down again. Put a measurement in between here and here. $210 we'll call it, which is way back in there. If these are not constrained, now here's a useful thing. If these are not constrained and we're not got anything selected, we can just grab this we should be able to just grab that and move it back. We can't because it is constrained. If we hover over that, we'll see a constraint. So that one, we delete that. And that one, we delete that. We can't just pull it back in. There's another constraint there if we hover over that. Delete that one. And that one. Still too many constraints for some reason. So what I'm going to do is just bring this in here and put a line here. Actually, this gusset goes right to the outside edge, so we might leave that. Let's click this and see how it looks. We're missing a face, but it's very easy to select it again. And that's not coloured in. Look at that there somewhere. Where is it not touching? Let's have a look. See what that is. And one of these lines somewhere don't actually add up. And there it is. Look at that. Move that one, and we have moved it. We see that hasn't quite lined up. We'll put that back on there so it clicks back in. There we go. Changes already. And if we have a look at sketch, that gives us 4, and we need 6 apparently. So very easy to change that. Edit the circular pattern. And where it says instance count of 4, we change that to a 6. Job's done. Fillets, I reckon. Probably. If we close that, we don't need another fillet open. There we go. So, matches up. You've said only 5, a couple of... I have here a picture that says absolute. I might be wrong, but I'm looking at a picture that says 6. Check that again, Mark. Mr. Phillips are driving you mad, that's right. Let's start again with the fillets and get them sorted. There's no fillets. Let's do this. Put all the fillets on the one. Those big glasses. Feel like we should leave one of these out for Peter. Give it a minute. But all our fillets in, almost. It hasn't got this one in. This isn't quite right. Let's sketch 3. And it says it's a 5/8 key. I don't know if it is. Is it a 5/8 key? Maybe it is a flywheel. we can actually just make this work. You probably put a formula in here so it's always, whatever you change the shaft size to, it's always in the center. We could very easily put a formula that says that this dimension needs to be half of that particular diameter, and if we have a list of if we use our, what's it called, our configuration panel or our custom tables, then we could put this diameter in on a table, and you could just change that diameter on the table, and it would change the keyway distance too and the size, which would probably be quite a useful thing. But 2.5, 1.25, we'll just do it like that, and that brings it back down on center. Can you set packet? That's a very good question. Can you circle pattern? Or I don't think you can on a feature. What you can do is put all those details on the feature. That's something you can do. That's just an order of operations thing. That's not quite the right shape on the back, because that's got a sort of an oblong shape here, and this is something that's definitely doable. But to give you some idea, that's where we're at now. Handholds. They're marked wrong in their absence, because we can change that. Then we had some measurements. So looking at Mark's picture, which no one else can see, they're about 92 by 67. So let's have a look here. Scroll this in using the middle roller on our 67 millimeters. And let's go 92 millimeters, because we can't be bothered converting them. Right click that, wait for everything. So like I get a T3 flywheel. I don't think it's exactly right, because I think there's more sticking out than that. Maybe I have got it pretty close. It wants really a fillet on this corner, and we could go back and change the drawing, or we could just do this. That should automatically work it out. That's pretty good, I reckon. Already set up, so to remember the dimension, the last dimension we used. All we need to do is click that. What it's done though is given us an error. This has turned out red, see? Because interestingly, we've got this little step in the corner. See that little step there in the corner? That must be on the first sketch. Let's have a look at that and edit it and see what we can find. Up here in this corner. Here we go. What have we got? Let's fix that. We'll delete that. And if we use the extend tool on this line, we can bring it out level with that. And that gets rid of that extra dot in the middle, which is very good. Anyway, we're way over again, but for some reason that hasn't fixed the problem, because we've only half fixed that. We'll get this sorted. We might call it. The issue is still here somewhere. Zoom right in. So same deal. We'll use the extend. And let's fix that. Let's turn it grey again. Little mark in the side there. So then when we do this, that should put a fillet in there nicely. There we go. So we're getting closer. We don't know how much dish is in this. We don't know how far offset this is. There's a few dimensions we don't know. We don't really have a lot of information about these dishes. If we have a look at Mark's photos, or if I have a look at Mark's photos, pictures from the back, pictures from the front, it doesn't show a cover that looks like mine. It's got a different style of cover that must fit onto this actual piece sticking out here. So it must actually push onto there or clamp onto there, rather than have 4 screws in here like mine does. So little differences. Anyway, so that's that. That's certainly improved our flywheel quite a lot. We can, that sketch is a bit ugly, so we can turn the sketch off, hide it, and there's a gusset sketch there too that's sticking out like. But that's certainly a very good start. There's a few dimensions we still need, but it's starting to look like a real sort of a flywheel. These gussets are probably a little bit, or the fillets in here are probably a little bit big. Quite easy fix. 0.625. Let's change that like that. Might look a little bit better. But without a radius gauge, it's very difficult. Exactly. Look, they've got 5 people watching. Everyone's a bit of a very quiet, but we've sort of had a look at a flywheel, a T3, fowler T3 flywheel, and what it sort of looks like. Some of the details on it. Just by putting dimensions on sketches and modifying them and changing them around, could probably that somewhere near. Without too many problems. I'd like to see a bit of a keyhole flywheel because that's what it actually had. And I'm not sure if we have a look at this. Yeah, that key's right on that gusset, but it has got an ugly sort of a bump here. Not a big deal to do. We got a minute? Let's do it. Put a sketch right on this face. And find a center point arc. Probably is something about what it has. It's a fairly ugly casting, but I think it's sort of something like that. And then probably it comes down here like this. If we miss all this, we won't have to redraw everything. Probably the easy way to get this the same. Or first we click a line and Q for construction line. Run a construction line up here. Press escape to get out of that. Use our scissors tool to trim that side of that one, and that one. And then use our mirror tool on that construction line to put come on, up. And we probably want to put a bit of a village on this because it is a bit of an ugly sort of. There we go. And that sketch is a lot less ugly than the one that we had. If we were to extrude that sketch, other way, wrong way, we'll go back the other way. Extrude it far enough so that it sort of sits there. It looks something like that. We'd probably go and put a Let's see if we can make this work. It's not going to like that very much. But it gives us something like what it should look like on the inside as well. Anyway, I might call that. You're getting a bit, and I'm sorry about that. But that's where we are. There's probably lots of other things we could do to make it tidy, but some more dimensions, and we would be very, very, very close to having something that actually looks like a fowler flywheel. Could break these edges quite simply. Put a chamfer on them. There we go. Change the edit appearance for that. If we open this to edit the appearance, this little screen pops up. We can change that there, but we can also, while we're here, we can click the other one we want to change as well. So we don't have to edit each one separately. Let's put a bit of a broken down. You've dragged on for way too longer than expected. Thanks for sort of joining in. It's really awesome to see you all, whoever you are. I got who else we got 5 others. Thanks for joining in. Hope to see you again. Love to see some of what you're doing or what you're actually making in this CAD program. I'd really like to see that. Now this is here, and this actual, I'll copy this across. So if you want to come through and have a bit of a play with it and mess around and put some spokes in it or whatever you want to do, that's it. No, we're not going to cast one. I'm resolute about that. I don't even think I have to think about that. We're not going to cast one, Peter. But there we go. Make a nice little paperweight in brass and about 1/10 scale. Anyway, I think I'm out. Thanks, guys, for tuning in. Really appreciate that. And ask lots of questions. Come into the CAD program via the link in the description box, and you can save this as your own, into your own studio, and you can mess around with it as much as you like. It's free use, so just go and do it if you want, and have a bit of a look at what you can do. Experiment, change the key sizes, change some diameters, see what you end up with. Put some cutouts on it and put some spokes in it, or redraw it completely with round spokes, or whatever you want to do. Very welcome to do it. Mark's working on steamrollers at Petrie tomorrow night. I'm just working on steamrollers. Anyway, that's how that is. Thanks, guys, and more soon, eh?